Today I will be showcasing how FlatBuffers can be used with Unity. First, we need to download the FlatBuffers repository. Inside the main folder, there's a folder called net that contains a C# project. We need to compile that C# project. I will be using Visual Studio for Mac. In my case, I had to edit the project file. I had to remove a few target frameworks. We will only need Net Standard 2.1. Now we can compile the project. Inside the bin folder, in the release section, we will have the compile DLL. This is the one that we will use as a plugin in Unity. Now let's create a Unity project. We need to create a plugins folder. Inside that folder, we will drop our DLL, and Unity should not show any errors. Okay, the next step in my guide is to download the compiler. We need a compiler because FlatBuffers, with FlatBuffers you have to create a schema and then compile that schema to whatever language you want. So in my case I will be using the Mac version. And this is the compiler. And so for this demo I have prepared an schema. There are many tutorials designed to, well, there is documentation to show how to create a schema. In this example I have a few types. I have a game, a player, an item, position, and a status. In FlatBuffers we have many types that we can use. The main ones are table, struct, and there are a few scalar types as usual, and an enum type that we can use. So in this case, a game is composed of a list of players. A player has a position, a name, a status, an inventory, which is a list of items. An item has an ID, an amount, and that's it. It's pretty simple. We need to define which one is the root object and create an 4-letter size identifier. After creating a schema like this one, we need to compile it. Now we need to compile our schema using the compiler. This command is telling us that we will create a C# version of this schema in one file, and it will create a C# file. The file created is not that complicated, and that file we will drop it in Unity. Now let's create some UI to test our code. Let's create a C# script to do our test. Now we just need to hook our buttons to our script. Okay, now let's test writing and reading using FlatBuffers. The first step is adding a few using statements, Google FlatBuffers, and the namespace that is defined on the schema in the first line. So the first step is create a FlatBuffer builder with the default size. Then we can start building our types. We can start building a game, and we have to end building a game. The end functions will provide us with an offset, and that offset tell us where is this object located inside the buffer. So a game had a few fields. It had an ID, and it had a list of players, a vector of players. For that we need to provide a vector offset. We need to create that vector before the game. We start the player's vector, we define the number of elements, and then we can finish the vector, and that will give us an offset. And we give that offset to the add players function. Now we need to add items to this player vector. We need to add players. We need to create it before. So let's create a player. And we can finish creating a player. And this will give us an offset to the player object. And we add that offset to the player's vector. We need to provide the int value stored in the offset. So player had a few fields. It had a name. A name is a string, and we need to create that string before creating a player. This will give us offset to that string. A player also had a position. We can, since position is an struct, we can add it directly. A player had an status, and a player had an inventory list. An inventory is a vector of items, so we need to create that vector before creating a player. We need to provide the number of items. I will add 3 items, and we can end the vector, and this will give us the offset to that inventory vector. To add items, since an item is an struct, we add them directly to the FlatBuffer. An item has an ID and an amount. Let's create 2 more. With different IDs and different amounts. And let's see, we have an inventory, a inventory vector added correctly to the player. We have the player offset added correctly to the player's vector, and we have the player's offset added to the game object. Now let's try to save this into a file. Data. We need to finish the FlatBuffer. with the root offset, and let's get the bytes out of the FlatBuffers builder. And let's save those files, those bytes. Let's call it game.bytes. Now let's just print something. And let's test our code. Now let's go to the root folder of the project, and we can see that the file was created, and as expected is just a bunch of bytes. Now let's see how we can read this file. Reading FlatBuffer file is easier compared to creating one. Let's first get the bytes from the file. And now we need to create a game object using those bytes. And now we just have to read the data. Game had an ID. Game had a list of players. Let's print the data for this player. A player also had a position. And a player had an inventory. Let's iterate over the inventory items. Let's print the ID of the item and the amount. And that should be it. Let's test our code. We can read the data. Game ID 1, one player. The player name was a cool name. Player status was attacking. Player position on the X coordinate was 1. The inventory had 3 items. Those items were ID 1 amount 15. We can see it here. With ID 3 the amount was 150, and with ID 4 the amount was 675. And the key feature of FlatBuffers is being able to read the data without doing allocations compared to other binary formats. So where this really shines, I think it's on mobile games, because the CPU and memory limitations, especially in Unity, the garbage collector is always something that we have to take into account, and this lets us read a lot of data without creating garbage. So next I will try to showcase how the Object API can be used as another option to read and write data using FlatBuffers. Okay, let's see how the Object API works, which is another feature that FlatBuffers provide. And for that we need to recompile our schema with an added option. This option will include in the C# file new code. And now we need to replace the file that we added in Unity with the new one. Now let's recompile. If we check the generated file, there are a few more types added ending with T, and so for each type we have, like game, we now have a new type called game.t, and those types make it a lot easier to create objects. So let's create a new function. And just as a normal game C# game object, we can start creating the data. Just filling it with the data that we want. Player had a name, a position, player had an status, and player had an inventory, which was a list. And an item had an ID. Let's create a new item. And that's it. Now we can save this data as a binary. And let's save this into a file. Let's use the same name so we can read it the same way. And let's see if it works. Let's create a new button. And let's see if it works. If we will read the data we had the last time. Let's overwrite that file and let's read it again. So I made a small mistake. I was supposed the name of the file was supposed to be game.bytes. Let's do that correction. And let's test again. And let's write the data. And let's read it. And we can see that it has the data that we just created using the object API. Name, attacking, 2 inventory items, ID 5, ID 78, and 34. And it was way easier, but this has a lot of allocations compared to the other way. In one of the cases I'm using FlatBuffers, I am saving files in the editor, so I don't really care if it's expensive to create the FlatBuffers file, so I am using the object API. But if you need to write files in runtime in your game, you might want to do it using the old and difficult way. There's another feature that FlatBuffers provide, and is that using the object API you can also read and write JSON files, and I want to show that. For that we need to recompile our schema. with a new option called cs-gen-json-serializer. Let's recompile. Let's update the generated file with the new one, and we get an error because we need to use Newtonsoft. So let me install Newtonsoft. Now that we have Newtonsoft installed, we can try to use the new features. And instead of saving to a binary file, well, let's save to a JSON file. And let's save this into a new file. Let's call this game.json. And let's see how it looks like. Now if we check the root folder, here is our JSON file, and this is our data. At last, let us try to read that JSON using FlatBuffers. Let's create a new function. And let's read the file that we created. And using the type that the object API provides us, we can deserialize from JSON. And we can read the data as expected. Let's add a new button to read the JSON file. And let's call our function and let's test it. And there's the idea of the game that was saved on the JSON file. And I guess that's it. you can mix and match all the features that you need, and I hope this is helpful. Thank you.